Hello everyone. We'd like to introduce Embedded Target for Virtual Platform. It's a tool to generate co-simulation environment of MATLAB model and virtual platform, hereinafter VPF. VPF is a simulator of entire microcontroller. It is possible to develop software before working sample is prepared. What's Embedded Target for VPF? Embedded Target for VPF is an application design tool to shorten development period. It transits from algorithm design to implementation and verification for application design easily. The customer designs vehicle system algorithm using MathWorks MATLAB and simulates it in algorithm development phase. However, since the device information is not dealt in algorithm development phase, the customer cannot detect the performance issue. To resolve the issue, current development style needs about 3 months to construct environment manually. By applying Embedded Target for VPF, these tasks can be completed for 3 minutes. From next slide, we'll explain the requirement, issue and solution of Embedded Target for VPF. We'll demonstrate it to show you the effect. About requirement of Embedded Target for VPF. Advancing E-architecture is requirement in automotive industry. Customers want to check the performance of their algorithm on actual processor early. To realize it, there are 2 requirements. Requirement 1 is shift left. The requirement is a method to check performance in algorithm development phase. Requirement 2 is shorten development period. The requirement is a method to create environment using processor in a short time. For each requirements, there is an issue respectively. For requirement 1, issue 1. Wait for the hardware working sample occurs. For requirement 2, issue 2. Spend a time to write the peripheral driver code and prepare co-sim-env with VPF occurs. The solutions to resolve these 2 issues are the right side. Issue 1 can be resolved by using VPF, which is prepared before hardware working sample. This is solution 1. Issue 2 can be resolved by generating peripheral driver code newly and co-simulation environment with MATLAB and VPF. This is solution 2. Embedded Target for VPF has these 2 solutions. This is a content of the demonstration. We show you that Embedded Target for VPF can detect the performance issue in early design phase easily. After preparing MATLAB model, Embedded Target for VPF conducted the following tasks. Add peripheral block set. Set parameters to block set. Generate application and peripheral code. Generate co-simulation environment. These generation can be finished within 3 minutes. After simulating it, if there is a performance issue, the algorithm is modified, or the block set is changed, or the parameters are changed. And it is simulated again quickly. If the performance issue can be resolved, the algorithm is okay. Next, we'll show you this demonstration. Hi everyone. Let's check Embedded Target for VPF on the T model. This model contains 3 main parts: the driver, the vehicle, and the monitor. At first, we run model simulation in algorithm development phase. It means run on MATLAB side only. Result of signal fuel _ ratio can be observed from this scope. We capture the result for comparing later. We expect the result are same. Now, we want to run model simulation in implementation phase. Let's go to Block Engine Controller, ENG_CNT. Engine controller is the algorithm which will be executed by CPU simulator. This is the verified target. Embedded target for VPF provides peripheral blocks such as WAT, port, ADC to communicate with engine controller. Here, we can change the basic setting of peripherals. For example, baud rate in watt, port channel and so on. Setting build tool, and execute command run_vlab on MATLAB console. Program is built automatically. Then, the program is executed in virtual platform and MATLAB. We open the scope to compare result of model simulation in two phases, algorithm development and implementation. As you can see, the result is different at some step. This is the problem. Let's check the engine controller's execution time. This graph you show the execution time of controller block in one step. The green lines show the execution time, it's around 4.5 milliseconds. The red lines show the periodical time of controller block, it is 2.5 milliseconds. We can see that the execution time exceeds periodical time. This is the problem. To solve this problem, we can go to controller block and modify block to reduce the execution time. In this demonstration, we remove unnecessary loop function which take much time. Then, save the model. We re-execute the model simulation in implementation phase. We check the execution time. It is smaller than periodical time now, which is good. And, we got new scope result. Two signal are matched now, it means we solve the problem successfully. That's all for our demonstration. Thanks for your watching.